welcome back, everyone. We are going to be doing some writing. So by now you've gotten your test back. You've identified your I knew it, I'm going to work on it, I'm going to learn from it. And because for most, in kind of all my classes, the radicals were kind of a big concern in general, I want to just really quickly kind of give a couple more examples and really answer your specific questions on how to do the radicals. So I want to start here in your notes for lesson 9. So if you'll join me on your notes for lesson 9. By now, most of you should have a lesson 9 KWL done on the next blank page. So here's the space that I have. So I will put in a K, a W, and an L sometime very, very soon. One for every assignment. So that way you're constantly looking back at every assignment and going, this is what I knew how to do, this is what I got to work on, this is what I'm learning. Okay? And I'm going to take the notes that we're going to do today here under the Learn section of Lesson 9. So if you don't have a Learn section yet in Lesson 9, you're more than welcome to take these notes in here because it pertains to this. Or you can do it if you selected one of the radicals as your Learn from the test. You can do it under there. Your choice. All right, before we start on the KWL fully, I'd just like to kind of go over real quick and make sure that we're feeling comfortable with the anatomy. How are we doing on the anatomy? We know where everything belongs, the names of stuff. Feeling good? Silences, I'm going to assume that you're not feeling good.
It's great.
It's great, okay.
Oh, for that.
Yeah, we're feeling okay with just this one right here. That's the only thing we're looking at.
No.
Feeling okay with it?
Yeah.
No.
No. Okay.
No. What part of the anatomy is weird?
Everything.
Everything. So the thing that is the actual radical square root symbol, we formally call it a radical. That's its formal name. Okay? There's going to be sometimes a little symbol right here. Usually a number. When you hit in the higher maths, they're going to change it to variables and things. But right now, you're going to see it mostly as numbers. If you don't see a number there, assume it's a 2, which is why we call this thing a square root. Okay? And it's called the index. The thing inside, regardless if there's an actual exponent or power involved, is called a radicand. And there's the radicand's power if there's one shown. So far, so good? That part? Did that help? Feeling a little better? Yes? No? Yeah? Okay. This rational is just if you have something that looks like this, you can trade it in for something that looks like this. And if you got something that looks like this, you can go back here. We're going to use it a bit more later on. Not so much right now, but I just wanted to introduce it to you so that you could see it and have some familiarity from when we get back to it, okay? All right, let's look at the product property. Anything about the product property that looks weird? Now that the anatomy feels a little better, this looks better. All right, and then going to quickly look at the quotient property. Anything about that looks weird? I've got a few kind of half nods. This one looks a little weird.
On the top,
where?
on the top, how do you know to use 4 and 5?
Great.
I would use 10 and 2.
That's a fantastic question. As soon as we get to the examples, we'll discuss that. Thank you. All right, so the quotient property then looks okay. All right, let's go ahead and go to the example so that we can handle your question. I am in the L section for my lesson 9. Yeah. Just on the next available blank page. Remember that you need to leave an empty page after lesson 1. We're done with it. So you're going to leave a blank page for lesson 1 for that assignment. Leave a blank page for it. And then the next page will be the test. That's perfect. Yep.
So like this can be used, like that can be considered blank, right?
Right.
And then this right here, I would put the test.
You can put the test there.
I already put it in this one.
You already put in the next one. That's okay.
I don't have an extra page, like, to continue on.
Okay.
So I just go to
Completely new page. Yeah. All right, here we go. So the question that we had earlier was, when we've got something that looks like this, and please forgive my line here. You don't have to have this one. It's a leftover from when I got my page set up for notes. But when we've got something like this, and we've listed our factor pairs, the question is, how do we know which factor pair to use? Because with 60, we actually have quite a bit. We have 1 times 60, 2 times 30, 3 times 20, 4 and 15, 5 and 12, 6 and 10. And then we start repeating, so that's about where we stop. But out of all of these factor pairs, the main question is, which one do we use? And the answer to that question is, select the pair where one factor has a perfect square root, which means the square root of it is a whole number. Okay? 2 and 30 was the one that was offered. Does 2 have a perfect square root? No. When you, does 30? No. So this one's out. You said 4 and 15. Does 4 have a perfect square root?
Yes.
Then this is acceptable and I don't have to check 15. I can if I want to, but I don't have to. She read my mind. So now that I've selected my pair. Yes, ma'am.
What if they both have a square root?
Awesome question. If both of these have a perfect square root, then the entire thing originally had a perfect square root. Okay. Yeah.
Oh, true.
All right. So we're going to rewrite this one. We're going to rewrite 60 as its factor pair, the one that we selected, because one of those factors had the perfect square root. Did that answer your question on how do we know? All right. Thank you. Yes, ma'am. No, if you're feeling comfortable with this, this is not your, only if you're feeling that you need to. If you're one of those that, you know what, I really got this, I'm just going to have to pay attention to make sure that I've got the justifications down while I work on something else, that is completely okay with me. And I'm sorry for those of you who are starting to write and are like, oh, waste my time. I'm sorry that I didn't clarify before. I'm sorry. Please forgive me. Okay, using the product property of radicals, because that's the property of radicals that deals with multiplication, I can rewrite this thing as 2 different radicals, and it gets broken at the multiplication. And now I can evaluate. What's the square root of 4? Just 2. Not the square root of 2. I saw this on a couple papers, kind of across the board, this class and others, that they would do this. You wrote the square root of 2. The square root of 4 is not the square root of 2. The square root of 4 is 2. Just 2. Okay? Now, we hadn't looked at 15 to see if it had a perfect square root, and we need to decide whether we're going to continue or whether we're done. So the question is, does 15 have a...
No.
It doesn't. So can we write it as a pair of factors where one of the factors has a perfect square root? I don't know. Let's run the factor list again really quick. 1 and 15, 3 and 5. Okay, we know that we're going to throw 1 out because that doesn't do anything. Does 3 have a perfect square root? Does 5? Then there isn't anything to do, and so we're done. And I kind of heard a side comment, was kind of soft, that this takes so much time. And yeah, the process itself kind of does. You can speed it up by getting more and more comfortable and more fluent with finding those factor pairs, by getting some of your multiplication tables memorized kind of a little stronger so they come quicker, and seeing those patterns of those things that have perfect square roots. Yes, ma'am?
So then that itself, just like that, would be the answer?
This would be the final response. This is the end of where you're trying to get to, your destination. The answer is all of the work you took to get there. Everything you did. And that's the main difference between this course and any other math course that you may have taken up to this point, is now we don't really care about what the answer is. In many cases, I'm going to hand you The end. This is the result. This is where you need to get to. I want to see how you get there. What steps do you take?
What if, say, like, instead of being 15, say it was 12, and so you went in, and so it would be 4 and 3?
You'd have to keep going. And you keep...
How would you write that?
Okay, so let's change. The question is, what happens if this number is 12? Okay, so I'm going to do it over here. We're going to redo with whatever, and we're going to say that we ended up with this. I don't know what came before.
How would you justify the last answer we had?
You remember each step the conversation we had? We listed the factors, then we rewrote, then we used the product property of radicals to break it into 2, then we evaluated the square root of 4. All of that would be the justification. This is what I did, and this is the name of some sort of property or definition or something that allows me to do that. Okay. So her question was, what if when you do it, you get into here and you recognize that you can rewrite 12, or whatever you have in there, as 2 factors where one of them is the perfect square? What do we do? And the short answer to that is, you do it again. The exact same thing you just did. You keep going. Square root of 4 is? And so the question is, well, I did everything. Am I done? No, why not? Because you can multiply 2 times 2, so you must multiply 2 times 2. Is there anything else that I can do for this? No. Now I'm done. Okay. So the short answer is keep going until there's nothing else to do.
So even if the one inside,
Okay.
so if the radicands can still be simplified, he still continues?
You must continue. And it is not done until you continue and you get to the point where there's nothing else to do. And so I can't award full points because you're not done. Make sense? Yeah.
Yeah, I'm kind of just like, I feel mad at myself. It's so easy.
Because it's so easy. Sometimes you just need to look at it again and have a fresh moment. And I understand that test time is a high anxiety moment. It's a time where you're like, oh my God, there's pressure. And so you feel kind of this stress, right?
I felt pressure
With the time limit. Yeah, and and the first test of the year is always really telling for me. It tells me what each class can handle and what it can't. And so I think that moving forward, I'm probably going to do fewer questions on the test. Yeah, I looking back and just having watched your faces and your body language as you were taking it and the timing of people turning things in, it might have been maybe 1 to 2 questions too long. So I expect to knock off maybe 1 or 2 questions, especially the justification ones. Yeah, you're welcome. Yeah. All right. Were there questions on the ones with the quotient property? Or can you see now that you've seen with the product, can you see how to do a quotient?
Can you do the last radical question?
Okay, I won't do the exact one because I've got someone in here who still needs to take the test. But I can do one very, very similar. Okay, so one that looks something like this. Yeah? Okay. As stands, there's nothing that we can do with it. Because if I divide 3 by 16, I get a decimal. And then I try to take the square root of a decimal, and I just get more decimals. And I said, no decimals. And you guys are like, ugh. So right now, nothing to do. But recall that the quotient property says that if you've got something that looks like this, some fraction inside of a radical, I can trade that whenever I want with 2 radicals written as a fraction. I have a fraction written inside of a radical, and so I'm allowed to trade it. The big question is, should I? And the short answer to that is, try it. If it helps, if it gets you where you need to go, then yes, you should. And if it doesn't, then you go, well, that didn't work, and you go back to before you did it, and you try something else.
Wait, so does that mean like you can multiply 6 times 3 and then you can find another
No.
I'm confused.
Okay, so right now we have something that looks like this, right? What this says is we can trade it for something that looks like this. That's all it says, which means I'm going to turn the numerator into its own radical and the denominator into its own radical. That's all the property tells me I can do. It doesn't say grab some other number, doesn't say multiply stuff. It just says rewrite it that way.
So then that would be your answer?
Have we done everything that we can do to it?
No.
What can we do?
16.
We can find the square root of 16, yes? So once we find the square root of 16, the top stays the same and the bottom becomes 4.
And that's it. And that's it.
Have we done everything that we can do?
Yes.
Then that's our final result.
So for justifications, we just put the property.
We use the quotient property here, and you can take that one, I'll accept that. You can take that one more step and go, I evaluated the square root of 16. Okay. Make sense? That help?
Sure.
I got a finger nod. Do y'all watch America's Next Top Model? You used to? Yeah. More than several seasons ago, lots of cycles ago, there was a girl from Rio Grande Valley, from Edinburgh, Sarah Longoria. And it was hilarious because she was in a shoot and the creative director photo guy was telling her stuff and she was holding it and she wasn't doing anything. And he asked if she heard him and she went, and he was like, what is that? He freaked out. And then later in the season you see everyone starting to finger nod. And it was fun. And then I ran to her Pan Am and I was like, oh my God. And she's like, oh yeah, hi. I was like, can I friend you? She's like, yeah, here's my Facebook. I was like, yeah, so I have her on my Facebook. She's really cool. She's hilarious. I love her. All right, done? Any other general questions on this? That whole story is going to have to get cut out of the recording. Any other general questions on this? All right. Alrighty, sounds good. I'm going to go.